And let's go ahead and let's stop talking in the back there on the side. And the three all by yourselves over there. Could you try to come over here and let's get this done? All right, so femto, as you see here, femto is F, and it's times 10 to the negative 15. So that's easy. So anything you see, let's go just with meters. And what we call this is a base unit. So the base unit could be meters, right? And if it's meters, then the symbol is M. If it's seconds, then the symbol is S. If it's liters, then the symbol is L, right? If it's, give me another one, give me another unit. If it's mass, then it's grams. So the symbol is G. So you can have femtometer. You can have a femtosecond. You can have a femtoliter. You can have a femtogram, right?
What's a femtogram?
Femtogram is 1 times 10 to the negative 15 grams, right? So this is the base unit. So at each of the base units, you can add some prefix. By the way, you could have a kilometer, a kilometer. You could have a kilosecond, right, theoretically. You have a kiloliter, theoretically. You have a kilogram, right? So kilo means what? Times 10 to the 3. You can have a terameter. You can have a terasecond. You can have a liter. And you can have a teragram. Centigram, centiliter, et cetera, et cetera, et cetera, et cetera. So all these could have different prefixes. The prefixes mean some kind of measurement, some kind of unit, some kind of factor. So kilo is what? Kilo is K, and times 10 to the 3, right? Tera is what? T, and what is it?
12.
Times 10 to the 12. Centi is what? C, and it's times 10 to the 2. Micro is that weird mu, times 10 to the what? Negative what?
It's negative 6.
Negative 6.
That 2 must be negative tera.
Thank you. All right. Giga is what?
Huh?
Giga is G,
Times 10 yeah.
times 10 to the 9.
And
And so giga is what? Giga is not million, giga is what? Billion. So when you have a gigabyte, you have a billion bytes of information. So remember that. Giga is a big number. Yeah. You have 6 more gigabytes of space, that's 6 billion bytes of space left. So nano is N, and how many? Negative 9. Pico is P, and what is it?
negative 12.
Somebody close the door. Milli is M, and it's what?
Negative 3.
Negative 3. See, this isn't hard, right?
This is
Yeah, because you looked it up. I get it. Oh my God, could you guys stop commenting on everything, please? So yeah, I told you could. You can look it up. You're going to have the units. It's there in front of you. It's not that hard. And mega is capital M, and it's what?
10 to the 6.
Times 10 to the 6. So there's all your factors. So now let's go see about the factor label method, which is what we did yesterday. That's all this is. Instead of brackets, they put it in this. Instead of using brackets, they used this little table-like thing. That's all. That's all. We could have used brackets. I could have took this. Let's go ahead and draw this out over here the way we did yesterday. And we could say, look, we have 3.4 liters. What I want is milliliters, right? And how do I get there? I'm going to put this over 1. I'm going to multiply times something that gets rid of liters. I know, that gives me milliliters. Well, how many milliliters in a liter is times 10 to the negative 3? 1 times 10 to the negative 3. Does that make sense? So I hear, but what? All right, so just like I said yesterday, I said it yesterday, right? So let me go ahead and do it clearly here. If we're starting by 3.4 liters, that's what I'm starting with. I'm going to put it over 1. Everybody have that?
Yeah.
Okay. I want to get how many milliliters? Remember we did this yesterday, yes? Everybody said, I understand. I said, okay. All right, so here it is. We're trying to get to how many milliliters. I got that many liters. I'm going to set it up. The way I set it up yesterday was this. I want to get rid of liters, so I want to cancel out liters, right? And I want to have, in the end, milliliters. Well, how many milliliters are there in a liter? What does milli stand for? What does milli stand for? 10 to the negative 3. So 1 milliliter, so it says 1 milliliter is 1 times 10 to the negative 3 liters. So now I'm going to go ahead and say that how many milliliters do I have if I have 3.4 liters? Well, I know that when I divide by exponents, what do? When I divide by exponents, what do I do with the exponents? When I divide something that has an exponent, I subtract the exponents. So this is, what do I do with this negative 3? When I minus 3, what is it? When I minus 3, wow. Okay, I'll try again. I minus a negative number, what am I doing? I'm adding it. I make it positive, correct? Negative of a negative is? Okay. So if I'm dividing by a negative number, it's no longer negative, correct? So the answer is going to be 3.4 times 10. The 3.4 times 1 is what? 3.4 times 10 to what? Times 10 to the third power. Milliliters. So there's 3,400 milliliters in 3.4 liters. It's just that simple. Now, instead of doing the brackets, they say they like to do it this way, which is the same thing. It's not that big a difference. The liters cancel, milliliters are left. What do you do when you have dividing by? This line means dividing by a negative exponent. You add the exponents. This is 0. There's no exponents here, right? There's 0. 0 minus 3. 0 minus negative 3 is what? Plus 3. So it's 3.4 times 10 to the third power milliliters. It's just that simple. This is what I just did. All right, so let's try this one. Let's see, where do we want to go? We want to go to meters. We're going to start with 13.7 centimeters. Which would you like to do it, with the brackets or with that line?
With the line.
The way they have it. So here's your line. Here's this line. So I start with centimeters. I'm trying to get to meters. So I want meters on top. I want centimeters on bottom. So I can do what with centimeters? Cancel them. How many centimeters in a meter?
10 to negative 2.
Well, 1 centimeter is 1 times 10 to negative 2 meters.
Okay.
Correct? But there's 100 centimeters in a meter. So I can do this. I can do 100 centimeters in 1 meter. Or I can do what you want to do, which is 1 times 10 to the negative 3 meters in 1 centimeter.
Why you got negative 3?
Huh?
Why you got negative 3?
Oh, I'm sorry, 2. Thank you. My bad. Negative 2 meters, correct? However you want to do it. if I put the number at the bottom, I have to put times 1 times 10 then positive 2, but whatever. So what do I do when I multiply exponents? I add them. So there's zero exponents here. Now, I could do two things. I could leave it alone, or I can do something else here. I like to do this. I like to turn this into scientific notation. Yeah?
How can you say that it's a 0 right there? I thought that's supposed to be a 1.
Where?
If you go back before you erase it, you saying that it's 13.7 to the 0 power, but it's 1.
Yeah, it would be 1, but it's 0 because there's nothing there. So if I really want to look at it, which is what I'm trying to say, so let me go ahead and zoom in here and do this. Instead of doing 13.1? I can do 1.37 times 10 to the first power, right? Is that correct?
No, it's to the second, and then move your decimal.
Yeah, 13.7 and then put 10 to the second.
What? 1.3 times 10 to the first, what would I do with that number? I'd move it over where? To 13.7. What's the number? 13.7. Correct? I just took 13.7 and I just made it into scientific notation. That's all I did.
I didn't know that's what you was doing.
No, it would be positive 1 because I want it to be, it's 13.7, not 0.137. Oh my gosh, you guys gotta follow along. You can't just jump in and out of conversations and then think that you're gonna understand. Let's try this again. I'm gonna try it again. I'm gonna move slow. You have the number 13.7. How do I express that in scientific notation? If I want to do 1.37
Times 10 to the first.
times, what do I do? What am I going to multiply this by? What exponent is 10 going to have to make this number turn into 13.7? 1. That's right. So it's 1. That's where it comes from. So 1.37 times 10 to the first. Why do I do this? Because then I can add and subtract exponents. Now I can do that, right? Now I can see how many numbers I have, correct?
And then it's gonna be.
So now it's 1.37 times 10 to the first times 1 times 10 to the negative second. So I'm adding the exponents, correct? So the coefficient stays the same. So 1.37 times 1 is 1.37 times what? 10 to what?
The
Negative 1.
And then you get 0.1.
Because 1 plus minus 2 equals negative 1. See, that's the trick. You have to add the exponents if you're multiplying and subtract them if you're dividing. So let's try kilometers again. And again, we're going to use that same method. Here it is. It's 876 kilometers. And I want to get rid of kilometers. And I want meters. Bless you. I want meters. So I want to cancel it. I want to get how many kilometers in a meter? Or how many meters in a kilometer? Either way. 10 to the third meters in a kilometer. So 1 times 10 to the third meters in 1 kilometer, correct?
Yeah.
So again, because I like to do it without a calculator, I'm used to it. I like scientific notation. It makes my life easier. I don't own a calculator,
So then it turned into 1.
even though my teacher told me it was on my supply list. I can take 876 and 8.76
Times 10 to the second.
times 10 to the second. That's correct. Now, when I look at this, I can see I'm going to do what with these exponents? I'm going to add them. So let me go ahead and move this over so we have more room. So I have 8.76 times 1 is 8.76 times 10 to the what? Fifth power, meters. That's it. You see how easy scientific notation is? How much easier your life is if you learn scientific notation. You have to learn scientific notation though. If you can't move that decimal around and put the exponent and remember that simple rule, if you're multiplying them, you're adding the exponents, you're dividing them, you're subtracting it, then yeah, it's going to be hard. But if you memorize those two little rules and do it, it's easy. Well, in these simple conversions, that's true. But remember, this is going to get. Look, I'm explaining to you how to do this simple method. But these steps, when you get into chemistry, you get in AP chemistry, you're going to have 6 steps. You have to convert it 6 to, it's called stoichiometry. You have to take it from grams, so you turn it to moles, and you turn from moles to number of atoms, and from number of it's all kinds of stuff you're going to have to figure out. So you can make a choice. Learn it well now and prepare yourself, or sit there and have conversations and kind of blow this off, not learn it well, and suffer next 3 years, and then into college. So you have 14,030,200 femtoseconds. You want to convert these into seconds. Shh. So what I would do is I would say 1.40302000. And I would say 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th power femtoseconds. And how many femtoseconds are in a second?
17.
10 to the what? Well, that's not quite true. There's 10 to the 15th femtoseconds in a second, or 1 second, or 1 femtosecond is equal to 1 times 10 to the negative 15 seconds. So you have to be careful, because if you're not sure what you're doing, you can confuse that. That's why you got to write it down correctly when you're writing your equivalencies. Pay attention to the details. This is easy, but the details can make you get a wrong answer. So now we can cancel femtoseconds now. And now when we multiply these two numbers, we're back to that long number, 1.40302000 times 1 is that number, correct?
Wait, don't you?
Correct?
Yeah, but don't
All right,
you
hold
add-
on. This number stays the same, correct? All right. Now I'm taking this, and this 7, I'm adding it to this negative 15. So what do I get?
-8. 10
Time-
to the -8.
10 to the negative 8 seconds. That's it.
I get it now.
See that big complicated number with that big complicated idea, all I had to know is how many femtoseconds in a second, and I got my simple rule, and I have my calculator. If I have to multiply some crazy number, I can do it. Here's 78,999 micrograms, and I'm going to write 7.899 times 10 to 1, 2, 3, 4 times 10 to the 4th power micrograms. And I want grams, so I'm going to get rid of micrograms, and I want grams. How many micrograms in a gram, or how many grams in a microgram?
You missed the 9.
I did what?
You missed the 9. It's 3 now.
Oh, thank you. So how many micrograms in a gram?
-6.
-6 grams. There's 10 to the positive 6. I go 1 times 10 to the 6th micrograms in a gram.
Why?
But if I wanted to, I could do, if I ask you how many grams in a microgram, maybe 1 times 10 to the what? -6 microgram, or grams in a microgram.
Oh, wait, I did that, I'm like, why was you putting that at the bottom?
So you can do it either way. Either way works, right?
The other way easier.
I like it whatever you want. However you want to do it. As long as you understand that what it means, you're good. If you don't understand what it means, you want to go get those copies? She knows where it is. Go get the copies. So now you just multiply again. It's 7. Let me zoom in. 7.8999 times
10 to negative 2.
10 to negative 2 grams.
I just told her that. I was about to use a calculator anyway.
So that's it. Yeah? Hey, wait, where's she going?
She not in this class.
Come here, Ashley. Where are you coming from? When? Let me pause this. Let me.
Yes.
So if the decimal's moving to the right, you're making it positive. You're moving it to the left, it's making it negative. That's correct.
So do this for
Hold on. Wait a minute. Hold on. Let me rephrase that. Hold on. Listen. Look up here. Look.
Oh, I was doing the
Look. If I'm moving if I got a whole number and I'm moving the decimal over, it's a positive. Because the reason it's positive is if I multiply this, which way is it going to move? To the right. So is when you do the multiplication, the positive exponent moves the decimal to the right. The negative number moves it to the left.
Can you do 18 real quick? Yeah, so it's going to be a negative 40.
Here, this is a positive 4.
18, we talking
Oh,
about
18. So let's go ahead and do it. So now I'm gonna do 8.4. You're not listening. 1, 2, 3, 4. So it's times 10 to what? Negative 4. Correct. It's not all you need. You need to know. You need to think about these
That's
things.
all I need to help with.
Oh, okay. Yeah. Yeah, you're turning it in before class on Monday. And the rest of it, I think that takes us through how you're doing it. There are some word problems I wanted to walk you through, but we've run out of time.
You want it on Jupiter?
Yeah, it'll be on Jupiter.
No, I said you want me to turn it in on Jupiter.
Yeah, turn it on Jupiter if you can. If not, you can hand it in the morning. Yeah, all of it.
But can you do this thing of this because you turn or is it
The kilometers, meters?
yes.
All right, come here. But see, come here and look at this. See, if you're going to change this to kilometers and millimeters, you have to do, either you have to find out how many kilometers are in a millimeter, or how many millimeters in a kilometer, right? Or you can just change it to meters and then change it to millimeters. So you do it 3 times. So let's go ahead and do it. 2.3 times 10
What's negative 4 plus 6?
2, 3, 4 to the 4th power kilometers, right? I'm going to go ahead, let me go ahead
I did this one.
I'm going to go ahead and say kilometers on the bottom, and I'm going to change it to meters. And there's 1,001 times 10 to the 3rd power meters in 1 kilometer. And then I'm going to put another line, and I'm going to get rid of meter, right? And I'm going to put millimeter. And there's 1 times 10 to the
I did this in
3rd
math
millimeters
class.
and 1 meter.
Okay.
So now when you look, you see kilometers is canceled, meters is canceled. And what you're left with is millimeters, which is what you wanted. Is that right?
Mm-hmm.
So
So why is it that we use 10 to the 3rd?
because it's 1,000 millimeters in 1 meter. Why put it in a scientific notation? So now all I got to
Oh,
do
okay.
is
But
just
it's
add
negative
these. Oh, it's one time said -3 meters in 1 millimeter. Would you rather use -3? Would that make you feel more comfortable?
It seems like we should use it. 'Cause
You could use it either way. If you're going to use -3 though, the -3 goes on the bottom. It's 1 millimeter equals 1 times 10 to the -3. If that makes you feel better.
Oh, okay, now I get it. Because you were putting this. Okay, that's
Yeah,
why I was
yeah,
confused. Because
yeah.
I didn't understand why you put it up there.
Yeah.
Okay.
So then, what we're doing then, what we're saying is that you add these two. So obviously the number here is 2.3, right? Then times 10 to what? 4 plus 3 is
7.
7. 7 minus negative 3 is?
4.
No. 7 minus negative 3.
4. I mean 7, 8, 9,
7
10.
minus negative
10.
3 is 10.
Okay.
And that's your answer. It's that many millimeters. You see how that goes? So you can actually extend that. This is the power of this system. You could have a whole line of these conversions. You can start with one thing and go through 8 or 9 steps and get that answer.
I gotta go Krupa.
All right?
Krupa don't like you.
I don't care.
Because all the students be
You're on the YouTube now. You're on YouTube saying that. Complete these for homework and these. So continue doing these problems, complete them for homework, and of course you have some word problems you're gonna have to figure out. All right.